All right, you should have a copy of this if I've seen you in person. Otherwise, this will be linked. I'm going to give you a very good example of how to do this process, number one, and you're going to do the rest of them for homework. I'm also going to move to the back and answer number 6, because these are 2 questions now that you know how to find a derivative that are going to pop up all the time. And I've given you graph paper on here, so we don't even need to worry about this piece of it. But what is going to happen is that these are the things that you will be asked to do, one of these 2 things. So it won't even give any of this A or B stuff. You'll be given a function and you'll be asked to find the equation of a tangent line at a given point. Or you'll be asked to find the equation of the normal line at a given point. And so in this case, it gave you a point. Sometimes it might just give you the x value. It doesn't have to give you the whole point. And so I'm going to kind of do that with you first off. Because this could just say at x equals 2 instead of giving you the whole coordinate. I'm kind of easing you into it by giving you the coordinates, but so your process is to do 3 things. To find an equation of a tangent line, you need to have a slope and you need to have a point. And if you have those 2 things, you can find the equation of a line. And the slope is going to come from knowing what the derivative is. So the derivative is going to give you the slope, and the point is going to come from the actual function because it has to be a point on the curve itself. So you have to play around with the derivative function and the function itself. So notation is a big deal. And I like the f of x notation a little better, but you're going to sometimes see it with y, sometimes with f of x. So really what you want to do is a few things. One, and the order of these isn't overly critical, but usually the first thing I do is I find derivative. So find the derivative, which is y prime or f prime of x. 2, find slope. You can't find the slope without the derivative, and that means plug x number into derivative. All right, then I know the slope. 3, find point. And this is where things get a little bit tricky because now I've got to plug x into my original function. All right, and I don't want, this doesn't make sense when I write it as plug x into y. So I'm going to erase that. That's why I like the function notation a little bit better. Plug x into your function, not your derivative. So the first thing I'm going to do over here is I'm going to find the derivative. So the derivative of my function is, well, actually, we'll sketch the graph first. I'm not going to shortcut you here. So this is from our power functions. This is a parabola moved down 3. So 1, 2, 3. There's my vertex. It goes over 1, then 2 would be up here at right there. I think it reflects over. So this is my parabola, and the better you can graph this, the better this whole process is going to be for you. And that's not very good, but there's my graph. All right, now I'm going to find the derivative. So now I'm over here finding the derivative. That was our first step. So y prime is, that's why notation is very important. We learned how to do this. The derivative of this is 2x, and so the slope is the value when I put 2 into my derivative. So the slope at x equals 2 is 2 times 2, which is 4. So my slope is 4. So now I know the slope is 4. I'm going to put a box around this, and I'm going to be crazy and call that, I'll write slope up here, but I might also put a little m right here because the slope is often represented by m. Now I'm going to find the point in which the slope is equal to 4. And again, notice that 1, 2, and there's the point right there on the graph. So I can find it on the graph. I gave it to you right here and then scribbled it out. But the y value when x is 2, I could just go 2 squared minus 3 equals 1. So now I have a point, and that point is 2, 1. Notice it's on the graph. And so if I want to do a tangent line, I can apply the slope to that point. So I know I'd go up 4, 1, 2, 3, 4 over 1. That's why my graph isn't very good. That really wouldn't be there. 1, 2, 3, 4 over 1. And I've got a tangent line here. And so now if I want to write the equation of this tangent line, we are going to use this idea of, I always go to point slope form. Y minus y1 equals m times x minus x1. And I'll tell you why in a minute, but I'll show you another way that many of you might want to do. Because now I have a point, that's all I need. And I have a slope, that's all I need. And so I can write this as y minus 1, because that's y1, equals 4, because that's my slope, times x minus 2. And this is pretty easy to convert to slope-intercept form. You distribute the 4, and then I add the 1 over, and so slope-intercept form would be 4x minus 7. The other way to do it would be to go straight to y equals mx plus b. And I don't know what b is, but I do know m, 4. I do have an x and a y value on the line. It's right here, 2, 1. So you can also go about it this way and go, well, 1 equals 4. My x value is 2 and my y value is 1 plus b. And let me figure out what the b is. 1 equals 8 plus b. Subtract 8 and you get your b value. And then you would put the 4 here and the minus 7 here and you'd have the same equation. So that's it. That's the process. It does take a little bit of work. It's not super fast and super convenient, but it is what you want to do. And you will be asked by IB to do that. Now I'm going to leave that up here, and I'm going to leave this here, but I'm going to erase all this for right now, because the second question is really question D, which is find the equation of the normal. And a normal line is perpendicular. So now I'm trying to find a line that's perpendicular to the tangent line at this point. So that's going to come through like this. All right, and I'm going to figure out it's perpendicular to the tangent line. So I already know it passes through the same point because it's going through that point I'm talking about. So I don't need that point, but I still need a slope for this. So a little thing to remember about the slope of a perpendicular line is that it is the opposite reciprocal. So if the slope of my tangent line is 4, the slope of my normal or perpendicular line, and again, normal just means perpendicular, that's all it means in British. So the slope would be negative 1/4. And notice, this one is very steep, up 1 over 4. This is negative and not quite as steep, so it's down 1 over 4. So I have my slope, got it, which I just got from this piece of information. I already know the point, so now I can use either of those methods to find the equation of the normal line. Again, this is the tangent line. I didn't erase that. I'm going to mark it now. Tangent line. And so if I want to find this other slope, I could go y minus 1 equals negative 1/4 x minus 2. And I can figure from here. Personally, I'm not a fan of fractions, so I'm going to multiply everything by 4. 4y minus 1 equals, 4y minus 4 equals negative 1x and plus 2, because I'm going to distribute that negative 1 once I multiply that 4 away. And 4y equals negative x, and I'm going to add 4 plus 6. And now I got to divide that away again. I guess I shouldn't have done that. So I get negative 1/4 x plus 6 over 4, which is 3/2. And notice how perfectly accurate this is. There it is, about 1.5 is my y-intercept. Maybe using the other format would have worked for that. This is a very important skill that you're going to want to practice, and it comes down to finding the derivative. Using the derivative, plug your x value in to get the slope. That is going into your equation of a line. To get the coordinate, if I didn't give it to you, plug the x value into your original function. Now you have an x and a y and a slope, and you can make your equation of a line. All right, I am going to move to number 6 because this is another very popular question that you will see often in the world of calculus. It wants to know the points on the curve, and here's my function, where the tangent is horizontal, where tangent is horizontal. So tangent is basically saying the tangent line is horizontal. That happens when the derivative equals 0. So you see this situation, you are finding when the derivative is 0. So Here you go. Step 1, find the derivative. Step 2, set the derivative equal to 0. Step 3, solve. And step 4, answer the question. All right, this wants points. Points are an x and a y value. Otherwise, it may just say, what are the x values when the tangent is horizontal? So whatever it asks for, make sure you give it to them. So here we go. This isn't too bad. Hopefully, I'm going to take the derivative. So the derivative of this would be 6x squared. The derivative of this is plus 6x. The derivative of that is minus 12. And this is where it's very important to remember that this derivative is 0, so it's gone. Now I set the derivative equal to 0. And I solve for x. Now this is a quadratic, so I'm going to factor it, but I notice that every single one of these terms is divisible by 6. So I divide everything by 6, and I can do that because I was consistent. Divide by 6, divide by 6, divide by 6, divide by 6. Now I can factor to get my answer. What multiplies to 2 that adds to 1 would be plus 2 minus 1. So my x value is negative 2. That's the 0 associated with that. And an x value equals 1. Now to find the point, I got to plug that back into this function. So if I put 1 in here, I'm going to get 2 plus 3 minus 12 plus 1. That's plugging 1 back into my function because the point has to be on the function, not on the derivative. And so I would get 5, 6, so negative 6. So one of my points would be 1, negative 6. Hoping I actually did my math correctly. Now I got to plug in negative 2. Not really excited about this, but if I put in negative 2, it's going to be negative 8 times 2. That's going to be negative 16. I put a negative 2 in here. It's 4. 4 times 3 is 12. So be careful of the sign. Oh boy, negative 2 in here is going to become plus 24 plus 1. And so I get 36, 37 minus 16 equals 21. So this is a y of 21. So my other point would be negative 2 comma 21. And those are the 2 points on the graph where I have a tangent is horizontal. Remember, this is a cubic with a positive lead coefficient. So its graph looks like this. Notice that I would have 1, 2 horizontal tangents. You just found the points of those horizontal tangents. All right, good luck with the rest of this. If there's questions, don't worry, we will go over this more.